So now you can see my computer. We continue value at risk and expected shortfall. Last time, remember, so we talked about the value at risk and expected shortfall, and we have our assignment. Okay, it's the end of the chapter 12, so you have an assignment to work on how to do value at risk and expected shortfall. I have the notes upload on Blackboard. Okay, this is the notes that we talk about. So we have the notes talk about here. So you can see, okay, that's the notes we talk about, for example, in the textbook. Okay, so to mute. Okay, so if they have a question, so you might to turn it on. If you don't have questions, so I wanted to turn your microphone as a mute. So we have example we talk about is, okay, make sure to type your name in the chat box. And so our date is already determined. So we have May, okay, May 4th. Okay, May 4th. Okay, that's gonna be the last date for me to turn in your final grade for graduating senior. So pretty much we're gonna have your graduating senior students to take your final exam, and you could the week after next week. So next week on Monday, so I will give you review questions for the final exam. So feel free to let me know if you have any concerns. And for graduating senior students who are going to graduate in May, you need to send me an email to confirm that, and so that I can get your final exam early. So otherwise, your grade will be reported late after May 4th. Okay, May 4th is the last day for me to turn in your final grade for graduating senior. So at least we have the final exam during the last week in April. Okay, that's very important to let me know. And so I already received some students' email to let me to have their graduate in May. But still, I'm waiting for some other students' email. Okay, so we talked about the value at risk. So I want to let you know is that the value at risk, we're using the VaR, which is the mu plus standard deviation times norms inverse of the x, which is the confidence interval, okay, or alpha. So we have two equations. One is equation 1, okay, the VaR, how to calculate the VaR. And also we have another equation is to calculate, equation 2 is to calculate expected shortfall. So expected shortfall with a confidence level of x, which is given in equation 2, right? Equation 2. So remember, so this equation, be very careful. So we can see there is a y here. So what is a y? Y is the x percentile point of the standard normal distribution. So basically, so you need to calculate y. So when you calculate y, it's going to be the norms inverse function. So you have the norms inverse, and you can get y. So okay, this is a norms n raised to the power of -1, and with x in parentheses. That's basically this part is y. Okay, so just wanted to clarify that. Some of the students asked me the question about that, and so we talked about the VaR and expected shortfall today. So we wanted to continue this topic. So what is the difference between VaR and expected shortfall? Okay, so we have VaR and also expected shortfall. Okay. So the VaR is a loss level that will not be exceeded with a specified probability. And expected shortfall, okay, expected shortfall is the expected loss given that the loss is greater than the VaR level. Okay, also is called CVaR or tail loss. Okay, that's okay, the difference between a VaR and expect shortfall. So you can see basically in this picture. So first you calculate the VaR, right? You get to the VaR, and you want to what is the VaR level, and the loss is beyond or below that level. Okay. So the expect shortfall is the expected loss given that the loss is greater than the VaR level. Okay, so now we have one-day VaR. So for example, you calculate a one-day VaR, what will be okay, we talk about the one-day VaR, and what about the yearly? Okay, so you have T-day VaR or one-day VaR. So you have one-day VaR, okay, daily volatility. It gets the result, it gives you one-day VaR. What about weekly, right? Weekly. So the weekly, remember the T is going to be 5, it's not 7. So you take the one-day VaR times the square root of 5. Okay, that's your weekly. And if you have wanted to do yearly, it's going to be 252 days. Okay, 252 days. Okay, 252 days, that's yearly. And if you do monthly, it's going to be the square root of 21. Okay, so I have a question here, which is the question in your textbook is asking about this. Okay. So we have the question 12.14. Suppose that the daily changes for the portfolio have first order of correlation, with the correlation parameter is 0.12. So the 10-day VaR calculated by multiply the 1-day VaR by square root of 10 is 2 million. So okay, so you already have, okay, this question is very interesting, is that you have the 10-day VaR. A 10-day VaR equal to the 1-day VaR. Okay, and then you times by, okay, so let's say you times this by square root of 10. Okay, that's good. So because we use this formula right here, so it's the TD VaR is 1D VaR times the square root of T, right? The T is 10 days. Okay. This is correct. Okay, the 10-day VaR is 2 many. So you got a 2 many. Okay, let's see, we just using that number equal to 2. Okay, 2 many. Okay, the question here is that, you know, a portfolio have first order correlation with correlation parameter equal to 0.12. So what that means, okay, when they have a correlation. Okay. So the correlation, remember, so we have a correlation and so we insert a correlation parameter. So this is the rho. Okay, rho is equal to 0.12. You have a correlation. So what that means, correlation is that in the volatility or the return of the following day is associated with the return of previous day. Okay, how they related to each other? Okay, the correlation is 0.12. So they do have a correlation. So if this daily price changes or the return have correlation, so this method, okay, is not accurate. It's not accurate. So we need to have a better estimate. Okay, how you do the better estimate? Okay, so I will show you in this book chapter we have okay. This is what I need to do. Okay. Okay, so if they have first order correlation, where the correlation between the price changes of the recent day and the previous day is a correlation. Okay. Then we have this way is that the standard deviation times 2 times the rho and the standard deviation squared is equal to, okay, 1 plus rho times the squared standard deviation. So when you sum them up, so that's we can have the equation which is 12.5. Okay, if they have correlation between the changes of the prices, so what you need to do is that to get this equation 12.5. So we need to have that, okay, 12.5. So let me get this equation right here. Okay, so if we have correlations, we're gonna use the 12.5, which is the equation we need to use. Okay, so the correct multiplier for the variance now it has to be, okay, so you can see this is the we have okay, now this is the 10 days, right? The 10 days and of this, okay, this is the I wanted to show you is this part, okay, in under that square root formula here. Okay, this is t is equal to 10. Okay, this is 10 plus 2 times, okay, t minus 1, which is 9, times the correlation, right? And plus 2 times, okay, t minus 2 is 8 days and times the correlation squared, 0.12 squared, and then plus 2 times t minus 3, okay, 7, and times 0.12 is a correlation squared, and plus, next one is going to be 2 times 6 times 0.12 raised to the power of 4, and until 2 times 0.12, right, and raised to the power of 9. So you sum them up, okay, this is this part, okay, under that square root, that is going to be 12.417. Okay, the estimate VaR should be, okay, this is the 10-day VaR you calculate, right? Okay, this is 2, okay. It's going to be the VaR you calculate which is 2 times the square root, okay, the square root of this part and divided by 10 days. That's the new estimate, okay, the new estimate VaR. So that's a 2.229. So basically, if they have autocorrelation, so you need to be cautioned that the 10-day VaR typically will have a higher, okay, will have a higher estimate VaR. So that's one thing I wanted to point it out. So last time we talked about you can use simply using this equation, right? You can simply use the equation. And so, but for if they have autocorrelation, so you need some adjustment. So that's we talk about. Next, about what is about the, you have the VaR. What about the expected shortfall? Okay, what about the expected shortfall? The expected shortfall, okay, I will show you here. Okay, so if they ask you the expected shortfall, so it's also you need this one, okay? The standard deviation of the change in the portfolio over 5 days. So you still have to calculate the correlation part. Okay, so that's similar to the one we did before, right? You have this formula. So as you do the correlation part, the standard deviation of the change in portfolio value over that 5 days. Okay, this part, and then you do is using the expected shortfall. Expected shortfall, this is the formula. Okay, so you still need to use this expected shortfall formula. Okay, so you have the mu plus the this is the delta. Okay, delta, and then you're using these numbers. So where you got the changes here, where you got changes, you see this one. Okay, the 5-day 95% VaR is going to be you're using the delta, change it to the new delta you just calculate using the autocorrelation formula. So this, okay, that's one thing I wanted to tell you or to mention about the if they have first order autocorrelation. Okay. So any questions? Okay, no questions. Good. Next, I wanted to show you is that let's go Yahoo Finance. So we do some real world data. Okay, let's see if you invest in SP 500. So we do SP 500. So what will be the value at risk, or expected shortfall. So you have value at risk. Okay, we click on the historical data. Okay, so let's download data for the most recent, like 1 month data. So April to time period. We just get 3 months, 5 days. Whatever, just we do 3 months. It's 3 months data. And we download the data. Okay, so we have this data for SP 500. So that's we delete the. So we have the data for SP 500 over the past 3 months, right? Over past 3 months, so we have that data. Now we can see the adjusted closing price. So how you calculate the return? Okay, remember how you calculate the return? Right? You can calculate return is equal to in the most recent day minus previous day and divided by the previous day, right? Return. Okay, so you double click. Okay, this is your double click and then you get a return. And remember we have another way, right? We have another way to calculate return is to ln of this previous day divided by current day, then divided by previous days, or adjusted closing price. So you have another way, right? So you just click on that. Okay. Either way, okay, is fine. So we just keep one of them. Okay, we delete the other one. You have the return. So now I ask you the question is about what is the VaR, okay, about the 5% VaR. What will be the losses, when you invest in SP 500 during the past 3 months. So how you do the VaR, okay? So the first what we wanted to do is, okay, you wanted to get the mean, right? The mean return. Okay, why you do that? Remember, so we have this formula. Okay, the mean, it's just the mean, and the standard deviation times norms inverse of the x. Okay, the x is the confidence interval. Okay, we do here, so we can do any type of data. So when you okay, so we have the average, select all the return. Okay, that's the moon. And also we need to calculate the standard deviation of this data. So now we apply to the real world data. So it's going to be equal to STDEV. So that's standard deviation of the return. For sure, standard deviation will be pretty high. Okay, so now you have the norms inverse, right? The y, which is the norms inverse function let's say 5% VaR. Okay, so we norms and inverse. So we have the 5% VaR. Half of the 5% VaR, which is the y. This is this part. Okay, this is norms and inverse x. So that's this part. So we wanted to know the VaR. Okay, 5% VaR. Okay, equal to. So what is the VaR? Equal to. Okay, so the moon, which is this one, plus, okay, standard deviation times the VaR. Okay, the norm's inverse. Right. Okay, that's your value at risk. So it's like you have 99% of confidence interval that, okay, or 99.5% of the confidence that your loss will not be exceed 8%, 8.19% during the past 3 months, right? But all you do is that we have okay, you have remember, so we have the function we used before is norm inverse. Okay, so we have the norm inverse norm in function. So norm in will give you the VaR, 5% VaR. Okay, norm inverse, and then they give you the probability. So the probability, that's a 5%, and you choose the mean and standard deviation. Okay, so you can calculate the 5% VaR exactly this the same. Okay, we have this 5% VaR, which is 5%. Okay, any questions? Okay, this is how you apply to real-world data, in real-world data. So now I ask you the question is about what will be the expected shortfall of 5%. 5% expected shortfall. Okay, do you have an idea as to how to do the expected shortfall? Okay, so the expected shortfall is going to use this function, right? This function. Okay, so I will leave this one right here. So to use the expected shortfall, and then you already have y, okay, which is here. Okay, you calculate expected shortfall of the SP 500 over the past 3 months, right? Okay, so I leave this question for you. Remember, be very careful. I did this part wrong several times in my previous lecture, so you need to check my formula exactly as what it is. Okay, so remember, so I have this formula right here, so you can check that to make sure you put some parentheses to make sure the calculation or the operation is in correct order. And so this is we do is that we assume that it's normally distributed and using the normal distribution VaR. And also we can do is a historical VaR. This is a historical VaR is also popular. Okay, what is historical VaR? Okay, the first you wanted to know the total number of observations. So you wanted to total number of observations. So you count. You count how many observations right here, how many returns. Okay, during the past 3 months, okay, the total number of observation is 39. Okay, 39%. Like, what about the 5% VaR? So 5% VaR. So you wanted to know what will be the 5%. 5% is equal to 5% times 39. Okay, it's a 1.95. So you wanted to know what is the smallest number. Okay, and the first is smallest number, and the second smallest number, right? So, okay, so you wanted to know what is the smallest number for the first one and the second one, because it's a 1.95. So you wanted to get somewhere between. So you calculate small, and that's what you need to know. And so you select all this area. So you wanted to know the smallest one. And then K is 1, the smallest, the first, okay, the smallest one. Okay, so you see all the returns right here. So the smallest number in all this return is negative 0, negative 1%. Okay, and then you do equal to small. This is the smallest of the area, the second one. Okay, you need to comma 2. Okay, so this is the second smallest one, right? Second smallest one. And if you don't believe it, so you can maybe you can do is later on we can sort the data. You can see which is the smallest one. Okay, so this is the smallest one, and you wanted to get the 5% VaR, which is a 1.95. Okay, that means is lower than the second smallest, a little bit lower than the second smallest, right? Okay, so you could do is, so what will be the 5% VaR, historical VaR? Is going to be, okay, you do the first smallest one, okay, plus, and you can see this is a 0.95, is less than this, and then you have the difference between these two, right? The difference between these two is this number minus this. Okay, the difference between these two. So 95% of that. So that's the 5% VaR you get. Oh no, it's a 0.95. There's a difference. We have, okay, the other way around. Okay, this is the difference. Okay, yeah. The second one minus the first one. Okay, so you can see this is going to be the 5% VaR using historical VaR. Okay, if you see somewhere, you can do is you select all the data. goes to data, and you sort the data by column G. Oh, so, okay. Before we do that, we need to select all this data. We copy, and then we pass. You could pass the values. Now no formula here. So yeah, make sure no formula here. So you just pass the values, and then you sort. Okay, the data you sort based on by G, in the smallest to largest. See, you can, when you sort that, you can see that's on March 16. That's the lowest. Okay, 11.9%. And then this is the March 12. It's a 9%. So, okay, remember these 2 days they have it's called a circuit breaker. Circuit breaker. So it's down below 7%. Okay, it's down below 7%. Okay, so that's the historical VaR. Okay, now do you have any questions? Okay, so now we're gonna end the meeting and see you next Monday. Okay, don't forget to type your name in the chat box.